Hey guys, welcome back to another training video. This is Chris and we are going to be focusing once again on Conversational CAM Pro. This video will entail specific details on the toolpath Turning Tool Profile. Now we want to answer two questions pertaining to this toolpath, just like the others, is we want to make sure we know what it is. Okay, how does the cutter actually go through the material in a certain way to give us the detail that we need, so you know what turning tool profile actually means visually. And two, how do we program it? How do we control it? Okay, if I want to have a profile cut at a certain position on a certain diameter, I want to be able to control that. So how do we program for that? And this video is going to answer both of those questions. Now CCAM Pro doesn't have the ability to generate any 2D CAD or any simulations, and so we're going to help visualize what this toolpath actually does using the Aspire CAD software to draw 2D layouts of what we want the spindle to become, and then we're also going to help visualize this on the back half of the video where we're going to show the cutting results of what the CNC is actually doing when the part is approaching the material with this cutting technique known as turning tool profile. Okay, so let's help visualize this first by going to our Aspire software. And in another video, we already showed how to turn the stock round. That was the turning round toolpath video. If you haven't seen that already, I recommend you go check out that video. Now, this is going to build upon this. This is why we did the turning round process first, because it is a core toolpath that has to be done as a priority before other turning toolpaths. Okay, so this technique is going to involve other types of cutters. You can still do a turning tool profile with a surfacing cutter, and we'll have other videos that will even show doing that. But this video is going to show how to take traditional style cutters that give us unique profile shapes and how to turn them around the circumference of at a single position along our part. Okay, so this cutter, as an example, is called a classic spiral cutter, and it's 2 inches in diameter. You can see the order number from Magnate, okay, is where we get a lot of these custom profile tool shapes. And so if we take this, I'm just going to copy it really quick so you can see what this is going to do. If we place this, let's see, remember that this section here on the end represents a square section. Same with this end here is a square section, but this middle section represents a round section that's been turned round to 2.5 inches already. Okay, so we're applying a detail to this round surface. So by placing this here along that face, what we've done is we've taken the entire shape of the cutter and put it within the surface of that diameter. Okay, so we're getting the entire shape. Now if we take that and we just do a mirror copy, I'm just going to flip vertically, you can actually see how it would be wrapped all the way around that circumference. And we can also draw some just straight lines here. This isn't necessary for programming, it just helps visualize, again, what the cutter is going to be doing to the material throughout this toolpath. And so if we give some straight lines here at these kind of transitional sharp pointed sections, that shows that this is going to be applying this cutter around the entire circumference of that diameter. Okay, so how is the cutter actually going to give us that result? Well, let's explain the toolpath. So the cutter, what it's going to do is it's going to take the tip of the cutter, it's going to position over where we want it to cut, let's say the x-axis. It's going to lower the cutter down to get to a starting surface. So this has already been turned around to 2.5 inches from our previous video. And so the cutter is going to start from that surface, and then now it's going to move down at a controlled speed, okay, as the stock is rotating until it gets to the final cut position. So the stock is continually rotating during that plunging motion, and once it gets to the actual depth, it's going to finish rotating a full rotation around the circumference, and then the cutter is going to lift straight up and it is done. Okay, it's a very simple but fast process that takes place by having the cutter positioned at a single point in the x-axis and then plunging while rotating continually. All right, and we can repeat that as many times as we wish. For example, if we take this, let's do a mirror copy to the other side. So we'll flip horizontally. And I'm also going to just go copy and paste and put another copy of this back to back. Okay, so you got two profiles back to back from one another. And you can see it gives you some slightly different results. If I just have a single cut at a single position, it gives me a very nice detailed cove within our turned round section. Whereas if I place two of these coves next to each other, it creates a bead effect within the turning. And so we have lots of variables where we can select different types of cutter profile shapes to give us almost unlimited design possibilities by combining all of these tools either back to back or in different ways. And again, it gives us a lot of possibilities when it comes to creating turn designs with this single turning technique, turning tool profiles. Okay. Now, this last step that I'm going to do here is not necessary for, again, programming. It just helps with the visuals. I'm going to take our scissors tool, the trim tool, and I'm going to trim away, because if the cutter actually plunged down here, this material wouldn't be left over, so I can trim that away. And you can see it just makes it look like it should. There shouldn't be a line going across the top if a cutter were actually cutting within the material at those locations. So let's go back to Conversational CAM Pro. And we're going to go manage this toolpath, showing you how to program it so that we can go to the CNC and see the actual realistic cutting take place. So we'll go to projects, and we are going to training samples. I already created a project for training samples like we're doing here. And in the turning center, we have a blank that we created from our previous, again, turning round video. Now, if I go to manage my toolpaths for this blank, we have our turning round toolpath in there. Awesome. Again, if you haven't seen that video, I recommend watching it. We're going to add another toolpath to this so we can see, one, that you can combine multiple toolpaths, as many as you wish, but we're only going to focus on one today. And again, it's the turning process called a tool or a turning tool profile technique. Okay, so let's add that. It's going to add it to the bottom of the list. Excellent. And we can close this. So now we have our tool profile that we need to program. So if we go into our tool profile, which is going to start asking us a series of questions, and so we can use this as a helper, but I'm going to try to explain what each one of these mean so that you know what is happening, because these questions are very abbreviated and you may not know if this is the first time using this software. Okay, so the first thing we get to do is we get to select the tool that we want to use for this turning tool profile. And that information I had back in this software right here. So it's the classic spiral 2-inch diameter cutter. That's what it is. That's the shape of the cutter, and even the order number. But we can go back to CCAM Pro, and it has the same tool library that I pulled that from. So if I click on this field here to open up our tool library, we can go here to classic spiral 2-inch diameter. And hey, that looks very, very similar, doesn't it? Okay, so that's the cutter that we're going to be using, and it has a lot of the details necessary to automatically start cutting with this tool. So if we select this tool, it will ask us what tool number we're going to assign this tool. Now, because this toolpath was added to the part file with another toolpath, for example, the turning round sequence that was done in the other video used a surfacing cutter, and we assigned that one to tool number 1. So if we were combining this with that process in a single part, this would be tool number 2. Okay, that naturally is how it would flow. Okay, so the section diameter. So this question is asking, where is the cutter starting to cut from? What diameter section? We kind of visualized that back in Aspire. I said that the cutter here, that the tip of the cutter has to come down to a known surface to start cutting, right? And so this is the diameter section, that process that's already been turned round. And that, if we actually measure that, we can throw a dimension out here, has been turned round, a vertical dimension of 2.5 inches. So that is our section diameter that the cutter is going to start cutting from. So instead of just slamming the cutter into the material really, really fast, it's going to start right at the material surface and then work its way into the material at a controlled speed, so we're not accidentally overloading any tools, spindles, or even the machine if we took things too fast. All right. So with that in mind, we can go back to CCAM and put in section diameter of 2.5 inches in diameter is where the surface of where the tip of the cutter is going to start from, that diameter surface. Now we get to put in the X position where we want the cutter to cut along the X axis. And this is really cool. I'm going to show you a cool tip here. And so if we go back to our drawing board, The cutter is going to obviously be cutting over here, right? Over that tool. Okay. I don't have to keep dragging this cutter around. I just wanted to show it where it was for the z-axis, so I'm going to get rid of that. But we know the cutter is going to cut here, here, and here along the x-axis. Now, in the previous process where we were using the surfacing cutter to turn the stock round, remember? It was starting, and it put the edge of the cutter at the starting point, and it put the edge of the cutter at the ending point, right? And it automatically calculated to do that for us for that specific toolpath, the Turning Round Toolpath. These other toolpaths that are being applied to an already round section actually don't require the edge of the cutter to be measured. We just need to measure to the center of the cutter. So if we go and grab a measurement here, just a dimension, from x0, same position that we had measured 0 from our other turning round processes, and we go here to the center of the cutter. That is going, oh, that's a vertical dimension, wrong one, horizontal, there we go. So if we go from x0 to the center of our cutter, that is going to give us an x position of 5 in order to make the cutter go to that location. While we're at it, I'm also going to find these other locations. We have 3 of these tool profiles taking place, right? So that one's at 11, and this one, the final one, the third one, is going to be at 13, okay? So originally, actually this is just part of CCAM Essentials, the basic conversational CAM, you would have to program each of these toolpaths, okay, each one of those cuts as separate turning tool profile toolpaths. Okay, that's just how it is. However, in CCAM Pro, we can actually combine multiple cuts in our tool profiles into one toolpath. So here we have 5, 11, and 13. We can combine them as long as we follow 2 rules. One is we're using the same cutter, okay, which we are, same cutter for all 3 of these cuts. We're using the same cut depth, so these are plunging into the material, the same depth for each one. And that's tied to the cutter shape, right, why we're using the same cutter. And it's being applied to the same section diameter. Okay, so for example, if this one here was being applied to 2.5 inches, but maybe these 2 were being applied to 2 inches, like there was a 2-inch diameter section, so they were smaller in diameter, then we'd have to put these 2 on a separate toolpath, and this one would be on its own. But in this scenario, because we've matched all the criteria necessary for this, we're using the same cutter, same cut depths with all along the same section diameter, we can apply the 5, the 11, and 13 all to the same toolpath. So let's go back in here to the x-axis position and go 5, 11, 13. Okay, so those 3 parameters just matching, 5, 11, and 13. Okay. Now we get to see all these other questions. Some of them are already pre-filled out for us, such as how fast it's going to cut, how much material it's going to take per rotation as it's plunging into the material. We'll get into a lot of those other details of how to optimize those when during certain situations. But for now, I just want to point out 1 or 2 extra things before we finish and save. Okay. The first one is this question, and so this question is asking, do you want to use the profile height, the shape of the cutter, as your cut depth? And in this scenario, we do. I mean, looking at this, the cutter, when we laid out the cutter originally on that section diameter, right, we were using the full depth of the tool when we position those, right? So yes, we want to use the entire profile height as our cut depth. Now, the cool thing about CCAM Pro is that it automatically has the cut depth parameter, that profile height, built into the cutter. And so if I go here to my cutters, I just want to show you that. So this is the cutter we selected, again, the classic spiral 2-inch diameter. There is a field here called profile height right there. So 0.432 is the parameter that represents the height from the tip of the cutter to the shoulder. You can actually see profile height is measured right there. Okay, so that's the cut depth that's going to be used automatically with this tool if we say yes to that question. So if we go back here with that tool selected, yes, that's going to be tool number 2. But here we say use profile height and keep it as yes. We don't even have to go measure our cut depth. It's going to take care of itself based on the tool library. Okay. Last thing I want to point out is that this is not being applied to a tapered surface. Just like the other turning round process was on a cylinder diameter section, these cuts are also being placed on a cylinder diameter section so that the taper is also listed as no. So we can now finish and save, and we have successfully programmed our tool profiles, 3 of them technically, with this one toolpath. And let's go generate some G-codes. We can separate our G-codes if we wish to do so, and manage our tool numbers in different ways also if we wish. So right now it combined the turning round and the turning tool profile all in one part, which is perfectly fine. If I was doing that and I need to do that, I can have both of those checked, and I can say generate my G-code, and it puts the surfacing cutter to turn it round first and the classic spiral in tool number 2 to do the profiles. Okay, excellent, that's great. But in this scenario, I've already cut the turned round section on my part, and I just want to add these profiles to that already turned round section that's in my machine right now. Okay, so I don't need to repeat the turning round process. I've already done that. I did that in the other video, and it's just waiting in the machine for me to do this. So let's generate the G-code with just the turning tool profile selected and generate G-code. And you can see now I don't have tool number 1 with the surfacing cutter in there. It's just now tool number 2 for the classic spiral. Okay, so we can save this G-code and go see what the final results are going to be. So we'll save G-code, and we'll go to quick access, and this is going to be not a turning round sample, but this will be a turning tool profile sample G-code. We'll save that, and now let's go out to the CNC and see what the cut results are. So just like we programmed, the cutter comes down to the section diameter of 2.5 inches, and from there performs a controlled plunge into the material while rotating the stock. Here, the default parameter in CCAM Pro is to plunge the cutter 1/8 of an inch per rotation until it gets to its final cut depth. And the final cut depth for this process was the profile height of that cutter. To finish, it rotates 360 degrees around the circumference and then lifts out of the material to repeat this process for the other 2 turning toolpaths. Again, all the cutting advantages of this turning tool profile are automatically built into CCAM Pro. You should now have a good understanding of what this toolpath is and how to program it. Now, these types of videos generate a lot of different questions. I recommend you take advantage of 2 resources to answer your questions. First is head on over to our website at legacywoodworking.com. There you'll find all the different product information, additional cutting demonstrations, and much more. The second resource I recommend doing is actually getting in contact with one of our CNC experts. You can call them at 801-491-0010. They will be happy to answer any of your questions, put on software or cutting demonstrations with the machines, and point you to additional resources, again, to fulfill your needs. Now, if you'd like to just simply watch more videos, I don't blame you. Just click right over there. I think we all know what to do. If you want to be notified of future videos, just click that button down below, and don't hesitate to give us a like if you liked what you saw. As always, thanks for watching, and remember, Legacy solves more woodworking problems and allows you to say yes to more opportunities than any other CNC manufacturer in the industry.